Hello everyone. Today in this video I will be discussing with you the second CPU scheduling algorithm, that is the shortest job first algorithm, that is SJF. Okay. Now first of all, I would like to say that this algorithm is for both preemptive and non-preemptive scheduling. Okay. So first of all, we will see the non-preemptive scheduling one. So non-preemptive we will be seeing first. So the question is process, then burst time in milliseconds. Okay, the processes are P1, P2, P3 and P4. Burst times are 5, 3, 7 and 9. Okay, now what we will do, we will draw the Gantt chart for this Gantt chart. Since this is non-preemptive, that means no running task can be interrupted, so that will be quite simple for us. So let's draw the Gantt chart. Okay. Now, as the name suggests, shortest job first, that means the process having the least burst time will be executed first. So here we can see P2 has the least burst time, so it will be executed first. So P2, that is 0 to 3. So this is done. Then we have P1. Okay, so P1 is plus 5. This was plus 3. So plus 5, that means 8. So P1 is also done. Then we have P3. Okay, so P3, that means plus 7. So that means 15. So this is also done. P3 is also done. And finally we have P4 with the maximum burst time, that is 9 milliseconds. So P4, and that equals to 24. So plus 9. Okay. So all the processes have been covered. So let's find out the average waiting time. So the average waiting time is equal to, for P2 the average waiting time is 0, so 0. For P1 it is 3, so 3. For P3 it is 8. Then for P4 we have 15. Okay, divided by 4, that equals to 6.5 milliseconds. Okay. So this was for the non-preemptive scheduling. Now let's see the preemptive scheduling example. So preemptive scheduling. Okay. Now for preemptive scheduling, one new column will be added to the table, that is the arrival time. Okay, so the arrival time will be added to the table. So the arrival time for P1 is 0, that for P2 is 1, for P3 is 2 and for P4 is 3. And I will also change the burst times. Okay, so this one is 8, this one is 4, 9 and 5. Okay, now let's start solving. First step is drawing the Gantt chart. So I am just drawing the Gantt chart. Okay. Now Gantt chart, start from 0, as the least arrival time is 0, so it will start from 0, and the first process is P1. Okay. Now this is 1 millisecond. Okay. Now at 1 millisecond we have P2 coming in. Okay. Now P1 has completed 1 millisecond. That means 7 milliseconds are left for P1. Okay. And P2, as it is coming in at 1 millisecond, and it has burst time 4 millisecond, which is less than 7 millisecond. That means, according to the name, the shortest job first, we will allow P2 to be executed first, as it has the least burst time in comparison to P1. Okay, so we will give the CPU control to P2. Okay, so here P1 has 7 milliseconds left and P2 has been given the control over the CPU. Now at 2 millisecond, P3 is coming up, and at that point P2 has 3 milliseconds time left, but P3 has 9 milliseconds, which is much greater than that of P2. So we will allow P2 to continue. Okay, as it has the less number of less time pieces than P3. So P2 will continue. At 3 millisecond we have P4, and at that point we have P2 with 2 milliseconds left. So we will allow P2 to continue because 2 milliseconds is much less than 5 milliseconds. So P2 will continue up to 5. Okay, at 5 P2 will end. Then we will give the CPU control to, so P2 is completed. Okay, then we will give the control to P4, as it has the less time slot. So we will give the control to P4. So it will continue till 10. Okay, then we will give the control to P1, as 7 is less than 9. So P1, and it will continue till 17. And finally we will give the control to P3, which will continue till 26. Okay, so let me explain it again. First of all, at 0 P1 is coming. At 0 P1 is coming. So I am giving the CPU to P1. At 1 P2 is coming. Okay, and at that point we have still 7 milliseconds of P1 left. But if we compare the burst times of P1 and P2, we can see that P2 is still less than P1. So we will give the control of CPU to P2. Okay. Now at 2 we can see P3 is coming, and it has burst time of 9, which is greater than that of P2, which has 3 milliseconds at that point. Okay, so we will let P2 continue its execution. At 3 P4 is coming, but P4 the burst time is 5, and at 3 the burst time of P2 which is left is 2 milliseconds. So we will allow P2 to complete its execution till 5. At 5 we will allow P4 to complete its execution because P4 has the least burst time among P4, P3 and P1. Okay, so P4 completes its execution till 10, and at 10 we are allowing P1 to complete its leftover execution because 7 is less than 9. Only P1 and P3 are left, so we are allowing P1 to complete its execution because 7 is less than 9. And finally the last process which is left is P3, and we are allowing P3 to complete its execution. So all the processes have completed their execution. Now we can continue calculating the average time. Now average time of P1, the waiting time of P1 is 0, but here again P1 has been given the control, so P1 has to wait for 1 to 10. That means 10 minus 1, that is equal to 9. Okay, so the waiting time of P1 is 9. First of all, it gets the CPU at 0, then again it has to wait until 10 after 1. So this is the waiting time of P1. So this has to be also added in the calculation. Then we have P2. P2, the waiting time is 1. Okay, only 1, because it is allowed to complete its execution without any interruption. Then we have P3. The waiting time of P3 is 17. Only, okay, because it has been allowed the CPU for the first time at 17, and then it has been allowed to continue its execution till 26. So it is 17. Okay, now if you can see here, the arrival time of P3 is 2. Okay, so the waiting time will be 17 minus 2, because its actual arrival time which was scheduled was 2. So the waiting time for P3 is this one. Okay, from 2 to 17. So 17 minus 2, that is 15. And then we have P4, which was scheduled at 3 but it arrives at 5. So the waiting time is 5 minus 3, that is equal to 2. So the average waiting time is equal to 9 plus 1 plus 15 plus 2 divided by 4, which is equal to, sorry, I have made a mistake in P2, because P2 was scheduled to arrive at 1, okay, and it has got the CPU at 1 only. So the waiting time will be 0. It did not wait and got the CPU as soon as it arrived. So the waiting time is 0. So this will be 0. So the average waiting time will be 26 by 4, which is equal to 6.5 milliseconds. Okay. So this was all about the shortest job first CPU scheduling algorithm. I hope you guys understood the algorithm and the numericals. Now if you face any problem, do let me know through my comment section, and if you like the video, please hit the like button, and if you are new to this channel, please subscribe the channel and share the videos among your friends. Thank you. I will be back with my next video on the priority scheduling algorithm. Thank you.